Every company you have ever heard of, Google, Netflix, Amazon, started in exactly the same place. A single laptop, a rented server, one machine doing everything. And here's the thing nobody tells you. That's not a mistake. It's not a laziness. It's the right move at the start. But here's what is the mistake. Not knowing what's actually living on that one machine. And not knowing when that machine is quietly becoming the biggest bottleneck in your system. In this video, we are going to open up that one server setup. We will look at exactly what's inside. We will see why it works, why it eventually breaks, and what to watch for when it starts to crack. Let's get into it. A single server architecture is exactly what it sounds like. One machine handles your entire application, the web traffic, the business logic, the database, and the file storage. Everything runs on one box. That box can be physical server in a data center, a virtual machine on AWS, or technically your own laptop if you are just getting started. The underlying hardware doesn't change the concept. Here's why it matters to understand this. Every architecture you are going to learn in the rest of this course is a response to the limitations of single server setup. Load balancers, databases on separate machines, cache, CDNs, all of it exists because at some point one box wasn't enough. So if you don't have a clear picture of what lives on that one box to start with, you won't understand why you are pulling things apart. Stick this in your brain forever. In a single server architecture, one machine is your web server, your application server, your database server, and your file server all at once. That's the whole setup. Imagine you run a street food cart. You do everything. You take an order. You cook the food. You handle the cash. You hand it over. You clean the station between customers. One person, one cart, total control. At 10 customers a day, this is genuinely great. Your overhead is low. You know exactly where every rupee goes. You can tweak the menu tonight and test it tomorrow morning. The feedback loop is fast. Now imagine the local newspaper writes an article about your cart. Suddenly 2000 people want your food on the same Tuesday afternoon. The orders piles up. You can't take the order and cook at the same time. The queue stretches around the block. Half the people leave. You burn 3 batches of food because you are switching between tasks too fast. By the end of the day, your cart is physically out of gas. Same cart, same you, just more demand than one person can handle. That's a single server architecture under load. The cart is your server. Taking orders is the web server receiving HTTP requests. Cooking is your application logic running the business rules. The ingredients and the recipe book are your databases. And the storage rack where you keep the pre-prepped containers, that's your file storage. At low load, running everything on one cart is efficient and fast. At high load, it's exactly the problem you have to solve. The rest of this module is about getting a second cart. There are 3 reasons you need to understand this architecture deeply. Reason 1. This is where every project starts. Whether you are building a side project, a startup MVP, or a proof of concept at work, your first deploy is almost certainly going to be a single server. Understanding it well means you set it up correctly and you know exactly when it's time to move on. Reason 2. Interviews ask this. When a system design interviewer tells you to design something at scale, they will almost always ask you to start with the basic setup before evolving it. If you can clearly describe what lives on a single server and why each component is there, you signal that you understand the foundations, not just the buzzwords. Reason 3. You can't split something apart if you don't know what the parts are. Every scaling decision you make in your career is going to be about pulling one layer off the single server setup and giving it its own machine. You need to know what those layers are. Here is where we are going. Let's walk through the anatomy of that single server piece by piece. Layer 1. The web server. When a user opens your app in their browser or taps something on their phone, a request goes out over the internet. The first thing on your server to receive that request is the web server. Nginx and Apache are the most common choices. The web server's job is narrow. Accept the incoming HTTP request. Figure out which part of your application should handle it and pass it along. Layer 2, the application logic. This is where your actual code lives. Your Node.js process, your Django app, your Spring Boot service. This is the layer doing the real work. It reads the incoming request, run the business rules, talk to the databases and build a response. On a single server, this code is running on the same machine that received the request. Layer 3, the database. Your application logic needs somewhere to read from and write to. On a single server, the database runs right there on the same machine. MySQL, Postgres, SQLite. The engine doesn't matter for this discussion. What matters is that every query your application makes goes to the process running on the same box. There is no network hop. That's actually one of the advantages of single server. Database calls are fast because they are local. Layer 4, file storage. Images, user uploads, generated PDFs, these live on the server's disk. Your application writes a file to the local file system and read it back when needed. Again, no network, just local disk. Now imagine 10,000 users hitting all 4 layers at the same time. All 4 layers are competing for the same CPU. They are competing for the same RAM. They are sharing a single disk. One spike in the database query slows everything else down. One memory leak in the application layer starves the web server. Everything is coupled to everything. That's the core problem with the single server setup. There is no isolation. I want to be honest with you about something most courses won't tell you. The good news, a single server is genuinely excellent for small scale. It is simple to deploy, simple to debug, and simple to reason about. When something goes wrong at 3 in the morning, you SSH into one machine. There is no distributed tracing, no service mesh, no inter-service latency to diagnose. Simplicity is a feature. Many applications, internal tools, small businesses, low traffic services run perfectly fine on a single server forever. The bad news, there is no redundancy. If that one machine crashes, your application is down for every user at the same time. You cannot scale one layer independently. If your database is the bottleneck, you cannot add more database capacity without also upgrading the machine that runs everything else. When not to use it, when you are expecting a rapid traffic growth, when downtime is unacceptable, or when regulatory rules require data isolation, at that point the single server has to evolve. By this time now, you are equipped to answer below interview question. Question 1. What is a single server architecture and what component does it typically include? A single server setup runs the web server, application logic, database and the file storage all on one machine. It's the starting point for almost every application. In an interview, being able to list those 4 layers clearly and explain what each one does shows that you understand the building blocks before you talk about scaling them. Question 2. What are the limitations of single server setup? The biggest limitation are the lack of isolation and the lack of redundancy. All components compete for the same CPU and memory. So a spike in one layer affects the other. And there is a single point of failure. If the machine goes down, the entire application goes down. Question 3. When would you recommend keeping a single server architecture instead of scaling out? For low traffic application where simplicity, fast iteration and low cost matter more than redundancy, early stage startups, internal tools, prototypes, these are all valid candidates. Adding complexity before you need it is its own kind of failure. That last one alone will save you in the interview when they push back on your first design and ask you to justify it. Before you go, take 30 seconds to log this in. Takeaway 1. A single server architecture runs the web server, application logic, database, file storage all on the one machine and every system starts here. Takeaway 2. Its strength is simplicity. Cheap to run, easy to debug, no distributed complexity. For low traffic application, it is completely valid. Takeaway 3. Its weakness is coupling. Every layer competes for the same hardware. There is no redundancy and scaling one component means touching all of them. Know these 3 things. They are the foundation for every scaling decision we cover from here. If this helped you, hit subscribe so you don't miss the next one. The full playlist is linked below. See you in the next video.